Welcome to clickmyproject.com. We will discuss about the product for simplifying clock gating logic by matching factored forms. Now we discuss about the abstract for the product. The clock distribution net and register typically use up 40% of power done by the processor. Techniques proposed for reducing the clock power include the blocking unnecessary clocking of register by clocking gating, using the dual edge triggered flip-flop to have the clock frequency, and sharing clock inverter by merging the several flip-flop into the multi-bit flip-flops. Clock gating is the most popular among these techniques and now has become a standard design practice. It involves the conversions of load enable register and to register using the clock gating. The clock gating is usually applied to the within RTL design. During the process, the clock gating is inserted, which contains the internal latch that filters out potential clutch from the block called as the gating function. In this paper, we propose a new techniques to simplifying the gating function. The idea is to use the existing logic for as far as possible while the gating function are synthesized. This is the achieved for matching factor forms of the gating function with these existing logic nodes. We call the technique of factor forms of matching. We will present here two matching forms: strong match, which looks for matches that are exhibitionally appropriate in an expression of circuit logic; weak match, which seeks match that are logically present but cannot be found in inspections. The gate level clock gating starts with netlist with partial or no gating applied. Some flip-flop are then selected for further gating to reduce the circuit power consumption, and the gating logic of the smallest possible size must be synthesized. Next, we will see the flow diagram for the product. First of all, the clock gating architecture to apply the source of clock input signal to passing the D flip-flop. D flip-flop is a just storage element, thus the clock control based storage element. The data is passed, the clock is activation, thus the data is passed to the D flip-flop. The clock is not activated, the data is not possible for the D flip-flop architecture. And the gating function to apply the clock with gating architecture. The gating function to apply the gating for the enabling separate architecture for the controlling the enabling signals to apply the gating function architecture. And the matching clustering forms. The clustering means multiple processing blocks is to applied and the same logic is developed by the architecture and to cluster the same logical functional elements. This the matching factor forms for the strong match conditions. Strong match is means by the set of tree functions is same for the overall tree architecture, thus the calculate the strong match conditions. These conditions to followed by the strong matching processing and the designs oriented process. The tree formation clock tree architecture to mainly focused by the hierarchical design arrangement, so only focused by the separate tree functions for the strong matching results, and the strong match result to analyze the separate same node formation for the each different subtree connections, then to apply the same node allocations and to reduce the clock gating architecture for our the overall clock gating circuit, and to final results are simulate and synthesize the clock gating architecture for our process. And finally, we run the output for the product. Just open the Xilinx ISC project navigator. The gating function architecture was developed by the VHDL language and to apply the structural modeling technique. Just we select the simulation model and to double click the simulate behavioral model architecture. The simulate behavior model function is to be run successfully. Then open the iSim project navigator. This file is used to simulate the results. Just we apply the binary input for the clocking signal and the D flip-flop data signal for our the clock gating architecture. Then apply the clock gating function and to modify the result output for based on the clock gating input results. Then to out implement the final results and to create the RTL schematic diagram to and create the schematic diagram. Just we double click the RTL diagram. These are the logical blocks for our RTL diagrammatic representation for overall clock gating architecture. Then the technology diagram. Thus the technology diagram will represent the number of lookup table and input output flip-flops and storage element, and then the wire connection to be processed based on clock gating architecture. Then calculate the design summary equations. Then the design summary synthesis report to generate the processing area for device utilization process. This the lookup table and flip-flop pair. Then the bounded input outputs is mainly based upon the area of clock gating architecture. Then timing summary, the delay time for 1.463 nanoseconds is the running time of overall running time of clock gating architecture process.